Pythagoras discovered the Pythagorean theorem, a squared plus b squared equals c squared. Since the time that Pythagoras discovered this theorem, mathematicians have studied right triangles to examine the relationships of the sides to each other. And pictured here is one of such of those relationships. We could go through the technical details as to how these relationships were found, and I can give you some specific places in which to look if you're interested in finding how those are found. But there's a formula that you can use in order to find the sides of this specific type of special right triangle. And this specific type of a special right triangle is a 30, 60, 90 triangle. Let me draw an example and then we'll look at the ones above. Okay, so a 30, which is represented by one arc up in my examples above, and a 60, which is represented by two, and of course a 90. Mathematicians discovered that, or figured out that, the relationship in every 30, 60, 90 triangle was like this. The value, or the measure of the side across from the 30 was always like the basic measurement that you would use or go by. Then across from the 90, always in a 30, 60, 90 triangle, across from the 90, the measure is always twice that size. And then across from the 60, the measure of this side here is the measure across from the 30 times the square root of 3. Now I'll tell you, when I first learned this, I thought, and you can tell I'm not the greatest mathematician because of this, I thought, well, if the measure across from the 30 is x, then this angle is twice that measure, so shouldn't this side be 2x? But it's not. It is this relationship. Now let's examine it above. Look. Okay, so across from the 30 is 7. Across from the 90 is 14. 7 times 2 is 14. And across from the 60 is this measure times the square root of 3. Okay, let's do it again. Here's a 30-degree angle. Across from the 30 is 2. Across from the 90 is 2 times that, so 2 times 2 is 4. And across from the 60 is the square root of 3 times that measure, so 2 times the square root of 3. Now this one's kind of tricky because look, here's the square root of 3 as a side measure. Well, let's talk about that. This is 30 because I told you that down here, one arc is 30 degrees. This is 30 degrees. Across from that is your basic measure. Across from 90 is 2 times that measure. Across from the 60, let's do the math to show it. So across from the 60 is that measure, is that measure the square root of 3 times the square root of 3. Square root of 3 times the square root of 3 is the square root of 9, which is 3. Now let's put that into practice. Let's do a couple of examples. And I'm sorry this is sloppy because I'm looking through my camera to do this video. Okay, so I'm going to say this is 30, this is 60, and my triangles are never drawn to scale, so pay no mind. And I'm going to tell you this measure is 20. So across from the 90 is 2 times x. Can I find x? Yes, 2x equals 20. So x is 10. So that's my basic measure. 10 is across from the 30. And then this measure across from the 60 is x times the square root of 3. So I have 10 times the square root of 3 is this measure. Now let's do one that's kind of tricky. And I always say don't be boring like me and I draw right triangles the same way every time. Okay, so let's say that this is 60 and this is 30. And this measure is 5. And I want to find the missing ones. Okay, so that's across from the 60. Across from the 60 is x times the square root of 3. And that measure is 5. If I solve this for x, I can find x, which would go here, And then I can multiply that answer by 2 and put this here. So let's solve for x. Isolate x by dividing by the square root of 3. So x is going to equal 5 divided by the square root of 3. As good little mathematicians, we're told to rationalize, so I'll rationalize this. 5 times the square root of 3 over 3 is this answer. And then to find this answer, I take x and multiply it by 2. So 2 times 5 square root of 3 over 3, make that 2 over 1, and that would be 10 times the square root of 3 over 3. It's very important that you learn these special right triangles, because when we do the unit circle, if you know this relationship for these special right triangles, then it will be easy for you to fill in everything on the unit circle.